Welcome to EASA Part 66, Module 8, Aerodynamics, Video 2. We will reinforce core principles, Bernoulli and airflow, tail download and balance, and steady level flight equilibrium. Format, quiz-style questions, diagrams, then concise explanations. Ready? Each question shows a diagram. Choose the best answer. Pause any time to think or take notes. We keep a single, clean animation style for clarity and continuity. Q1. According to Bernoulli, which statement about airflow over an airfoil is correct? Reference the diagram, upper stream labeled P2V2, lower stream labeled P1V1. A. Static pressure is higher above. B. Velocity is higher above, pressure lower. C. Velocity is lower above. D. Pressures are equal above and below. Answer: B. Velocity is higher above the airfoil and static pressure is lower relative to below. Bernoulli: as speed increases, static pressure decreases, contributing to lift with the pressure differential and flow turning. Q2. In steady level flight for a conventional tailplane, what is the typical tail force and why? Refer to the diagram. Wing lift upward, tail download downward. A. Upward tail force to reduce stability. B. Downward tail force to balance nose down moment. C. No tail force in trim. D. Alternating up to down each cycle. Answer: B. The tail typically produces a downward force to counter the nose down pitching moment and maintain trim. This down force supports longitudinal stability and balance about the center of gravity. Q3. In steady, level, unaccelerated flight, which relationship of forces is correct? Consider lift, weight, thrust and drag under equilibrium conditions. A. L, W and T, D. B. L, O, W and T, E, D, C. L, O, W and T, D, D. L, W and T, or D. Answer: B. Lift equals weight and thrust equals drag when flight is steady and level. With no net force, there is no linear or angular acceleration, but EASA under the condition for equilibrium. Recap: higher speed means lower static pressure. Conventional tail provides download for balance. Steady flight balances forces. Use diagrams to visualize pressure, moments, and vector balance. TF. Increasing angle of attack increases lift coefficient up to the critical angle of attack. TF. In a constriction, airflow speed increases and static pressure decreases. TF. A forward CG generally increases tail download and static stability. Great work. Revisit questions and diagrams until you can explain each principle clearly and quickly. Proceed to the next quiz when ready. Safe studies and smooth flights.